So we'll start by creating our backend project. It's going to be Java, Maven, CORS, CSRF, backend. Yeah, that's all cool. And we just grab the 21, and here we are. Then we grab Spring Web, we grab Spring Security, and those are the only two dependencies we'll be needing. Cool. We create this here. Nice. And there we go. Now, one thing I want to do differently, I want to go to, where is it? Here. I will take away the idea, and then I will just open it as a parent folder. And the reason I want to do that is because I want to have backend, and I also want to have front end in the same. And you guys don't have to do that. You guys can just, follow along for the backend. The only reason I'm doing that is because I want to have a front end Angular application to be able to show the full examples of how CORS and CSRF works, what the problems that front end will be having, and then show how it actually looks like when we solve it. So it's just for demo purposes. So we create ng new front end. It's just to create an Angular application here. Cool. So now that it's all done, I go to IntelliJ. I now have my backend project here, frontend project here. I'm just going to wait for it to index the dependencies. Now I will load the backend. So I want actually the backend to be added. Perfect. It did that. And then I'm going to go to here and to modules. And I want to add a module. So import a module. And I'm interested in this front end, the one that I created here. And I'll just press create. And we can see now that I have both. So I have a backend here and front end, and that's what I wanted. So I can, I don't have to have two IntelliJs open. I can just, stick to this. Cool. Then first things first, I'll just create a simple controller. Let's call it resource controller. And this will be the controller we will be using for our demo at requests mapping resource. We'll have a get method that will just return a string. We'll call it get current time or something. And will be return hello. It is and local date time dot now. Perfect. And we'll also have a post mapping to show how post methods work. And this will be public string update. Return something like updated user data. Right? So yeah, perfect. And then we also want to have a config. Here we will have our security configuration. And here, oops, we create a configuration class. Perfect. Then we do create our bean, public security filter chain, which gets HTTP security. And for now, I will just, show how it looks without anything. So, we'll just do it like this, disable, and CSRF C minus C dot disable, and of course dot build. So now it tells me it throws an exception. Yeah, no problem. And we can write both of this a bit shorter. So let's let IntelliJ do that. So yeah, it's a very simple setup. I'm just basically disabled CORS, disabled CSRF, and that's all we needed. So now if I start the backend application, let's do that. And I will also start my stack. I will grab a new window for this. Yeah, exactly. That's what I wanted. Now if I go to Actually, I didn't want 4200, I wanted 8080. And the resource, we can see that I can indeed get to the get to the to the resource that I wanted, and it all works. Cool. So now that we have our backend running, we switch to frontend, and I'll create quickly some demo so that we can actually test our application. So I won't spend too much time explaining what am I exactly doing here. Because it's front end, but it's relatively simple. I'm just creating, you will see quickly, in a second what exactly I'm creating. It's just going to be two different forms. One will be working with CORS, another one will be with CSRF, and you will, be able to see it all. Things that I'm missing here is an output. So it's just a string that I'm showing until I actually, instead of the title, until I get the resource, and I fetch the resource. Here it's yeah, we don't need this yet. We don't need this yet. Yeah, we only need this. And for that, we of course need a constructor. Constructor private HTTP client, HTTP client. And if we're gonna use an HTTP client, I of course have to use import HTTP client module. Perfect. So with all of this, we should be ready to go. Let's just quickly start our Angular application. CD frontend, ng surf. Awesome. So now we're here, and I'm gonna open this in a new page. Exactly. Let's just make it a bit like this, and you guys can see everything. Awesome. So we have basically two fields. One will be fetching it with CORS. Now, in case you guys don't know, CORS is basically a way to relax uh, same origin policy. So the idea is that because we don't want just anyone to be able to call our backend and grab the information using our authentication. Uh, so for example, you're authenticated, but if some other website could get you to click a link, and every time you click that link, they will send a request, and because your browser automatically includes all the cookies, and so your session will also be included, and then the domain will give all the information that actually belongs to you to that third-party website, which is obviously not cool. And that's why there's the same origin policy. Basically, by default, domain will, it's only allowed at the same domain, and domain is HTTP, localhost, and port, all of those three parts. HTTP or HTTPS, and then the full domain name, everything you see here. Only the same domain gets it. Even if its port number is different, or even one letter is different, or anything, or if it's a subdomain, you cannot by default get it unless you allow it with CORS. So CORS is a CORS origin resource sharing. You can get it. You can get it if you allow it on the server side. But right now, we turned CORS off. That means right now there is no CORS and there is no CSRF requirements on our backend. And if we press it right now, we see that uh, we get an error. But this error, and this is important to understand, oops, I misclicked. This error is 100% on the browser side. So what I mean by that, if we actually take a look at it, it was actually 200 OK. And so the request actually reached the backend, and backend gave it a 200 and gave it a response. But the browser realized that the origin from which it was made is not the same as the host, and that's why and it's also categorized as a CORS request. So it's a dynamic request. It's one of those fetch or XHR requests. And that's why browser blocks a response, but only after the response already arrived. So that means if this operation were to be some kind of a changing operation, maybe we already, like this operation tells backends transfer some money somewhere, then this operation already took place. It's only the browser is only blocking you to see the response. Yeah, that's just tiny things that's important to understand. Cool. And then we can also use this one, and CSRF is different. So CSRF is a kind of attacks that actually uses some loopholes in CORS, and one of the loopholes in CORS, or the main one basically, is that CORS does not block all requests. It allows simple requests, and specifically it allows posts made by HTML forms. And the reason for that is because those forms were existent before the CORS came to be, and not allowing them would just break most of the web. So they, for web compatibility reasons, they were allowed. So here, if you take a look, this submit, so the previous fetch with CORS as actual fetch that happens in JavaScript, but this one submit with CSRF is actually an HTML form. You can see it here. So it's a form and it has an action defined a method. And this does not get blocked by CORS. And I'll show you here. So when I do it, you can see that we were able to send the request successfully and we actually got the response back. So that's just, so this is just me showing you that both work. So this one gets blocked, but this one does not. Yeah, just so you guys understand. Awesome. Now that I've just showed you how this actually looks like, I will go ahead and show you how to mitigate them, how to fix them both. So let's start with CORS. First things first, we go to our security configuration, and what we will do is we will actually enable CORS. So instead of, let's just put CORS up right here. Instead of disabling it, I will do something like C, which is our customizer, and I will say, and I will create here a CORS configuration source, and it's just a lambda where we explain what we do with every request. And so what I do here is CORS configuration, let's just call that equals new CORS configuration dot, we got set which origins will allow. So remember the origins that we actually want, except the domain, our own domain. And we're saying that we want to allow the local host 4200. So that's one. Then we want to set which methods we allow. For our application, it's just the get and post. But if you feel like it, you can also add put and delete. It's depends on your, I mean, it makes sense to allow as much as you need to allow. So set allowed headers. For that, I'll just for now again, I'll just allow everything just for demo purposes. But of course, you should ideally specify every single headers that you actually want to allow. Set allow credentials, and I'll just set it true. This is just in case you want to set credentials on backend with cookies, which actually is not the case in this app, but yeah, I'll just add it for the sake of completion because normally for applications that sets cookies, you need it. Cool. And once we've got that, we just set it in the original customizer as configuration source. And there we go. And we restart our application. Perfect. And we can start our application again. Yeah, there we are. Cool. So if we try it now, we should see that this works as expected because now that we allowed the CORS request to go through. So our backend now allows the origin localhost 42.0, and that's why we can get it. And of course, CSRF still works. So this is also as expected. Cool. Now that we have CORS figured out, let's also protect ourselves from CSRF. That's a bit trickier. So with CSRF, when you work with single page applications, you first of all want to write here CSRF or something, csrf.set CSRF token repository, and we do cookie CSRF token repository with HTTP only false. And we need HTTP only false because the way CSRF works is the server will set CSRF token to the one of the CSRF kind of safe HTTP methods responses. So for example, when you do GET requests, and GET requests are seen as safe, and you should program your application in ways that GET requests don't make any mutating operations, you will get a CSRF token. And then your JavaScript application expected to grab that token with JavaScript and set it as a header as x minus CSRF, XSRF token in every single request. And for that, we supply this with HTTP only false, so that it is not HTTP only, and with a cookie that is not HTTP only can be grabbed by JavaScript. And the idea behind it is that even if somebody gets to, you to click some other page, on some other page, a link that would, perform some mutating operations, that doesn't matter because they cannot access this cookie because the cookie is limited only to the domain that we want. And because of that, they will not be able to supply it as a header and their requests will get blocked. So that's just a quick explanation. Why do we need all of this stuff? And right after this, we also do CSRF request handler. And here we supply the one that is we will create ourselves to deal with CSRFs when we have a single page application. And this is just from a Spring Boot documentation, a Spring Security actual documentation. Let's just create it here. And yeah, it's relatively simple. I actually wanted to implement, what do you call it? Yeah, requests, not request handler. I think it's a bit weird. I wanted CSRF token request attribute handler. That's what I wanted. Cool. And it has only this one method, which we'll deal with. But first we do CSRF token request handler, and we make our delegate, and this will be our new XOR CSRF token request attribute handler. And we just, for normal stuff, we just say, hey, this dot delegate dot, we just let him handle it, and we just give him request, response. Oops, where's the response? Oh, I'm confusing methods. So first of all, I wanted to do sorry, my bad. So resolve CSRF value, request CSRF token, that stays. But if the request contains a request header, string with tills or something, has text, request.getHeader, CSRF token get header name. Then we let CSRF token request attribute handler, so the superclass, deal with it. This applies when a single page application includes a header value automatically, and we just want the super to deal with it. In that case, resolve CSRF. Where's actual super? Something is weird here. CSRF token attribute handler. Let me just make sure that it's all correct imports. Yeah, we're working on it. It's not implements, it's extends. That's why it was freaking out. Okay. Resolve CSRF token value. So yeah, exactly. If it comes from the header, then we'll let the super deal with it. And in all other cases, let's say it's a request parameter, we will use our delegate to resolve the CSRF token, which we technically won't need in our case, but just being thorough. And we'll also, what do you call it? We will override the handle method. And in this case, we will let our delegate deal with it. So we always use this XOR CSRF token request attribute because it also provides protection against breach. Uh, and exactly, and that's why it's just a safer breach attack. It's just a form of attack which relies on, I mean, on compression headers, but we don't really need to worry about it. We just can count on the fact that Spring has implements defense against it, and we just need to use this class. But yeah, so we've got that part covered. And one thing that we're still missing a little bit is we want to create our own filter, CSRF filter, to actually provide the CSRF token. So let's call this filter. Let's add the CSRF cookie filter. And here we will extend once per request filter. And of course, we need to implement the to filter internal. And here we just do CSRF token equals CSRF token request get attribute CSRF. And then we do get token, and this line here will cause the token value to be actually rendered by causing the deferred token to be loaded, because there's a Spring basically implemented it like that the cookie is actually deferred, and that's why it's not loaded immediately to do some better performance. And we actually want it to be loaded here so that it actually gets passed in as a cookie so that we actually get it. So yeah, renders the token value to a cookie by causing the deferred token to be loaded. Cool. And then we, of course, whenever you work with filters, never forget to, like always remember to actually call the filter, otherwise you will get empty response. So cool, we have this, and now we take that and go to our security configuration. And we just have to remember to add filter after new, and then we just add it after basic authentication. Cool. So now, if we try now, so we can see that CORS still works as expected, and that's how it should work. But now if I try to do the CSRF, it will say, hey, no, you don't have the CSRF token. So what do we do about that? Basically, we have the XSRF token in our cookie, and you can see that here. So it was set as cookie, but we did not supply it as a request header, and that's why the backend rejected it. So if you take a look, this is our request headers. We do not supply it here as an x minus XSRF token. And for that, we need to do some changes in our front end that it actually, provided that it has a cookie and it will get it from the first GET request, it should also supply it for every subsequent request. So yeah, let's make that happen. For that, we just need to create an interceptor. Let's call this CSRF minus token.interceptor.ts. Then we go here, and again, for the interest of time, I will just copy the code so that we don't spend a lot of time typing TypeScript. But just to quickly go through it, just a second. I'm just handling the imports. And perfect. So these are the methods that in Spring in CSRF filter are defined as CSRF allowed methods. So for example, there will be no CSRF check, and they will be actually the ones delivering us our CSRF token. And if this happens to be not one of those methods, let's make some space here. So we get the value from the cookie, the value of XSRF token. Then if it happens to be post, put, delete, for example, then we will modify the request by adding this header, and that's it, and call next. Otherwise, of course, we just don't do anything. And that's just a helpful method to get the cookie value. And now I just need to do a little bit of a setup that we actually do provide this. So just a sec. So in Angular, you have to do a bit extra work to get to the interceptors, provide HTTP client, and let's do with interceptors from D. So dependency injection, and then we do here provide HTTP interceptors, use class CSRF token interceptor, and multi will be true. Cool. So that alone should be enough for us to start including it in every single request. As long as, let me just check it that I didn't forget anything. We have here, we have, yeah, exactly. And cool. So let's try now. And we fetch it with CORS, so we've got it. And now when we try to do that, we see that, oops, we're still not sending it. And I'll check why, but I think it's because I need to, oh yeah, no, my bad, of course. I forgot the most important thing. Well, yeah, I can no longer do it in HTML. I have to do it now in a JavaScript to actually add it, because HTML actions will not be intercepted by an interceptor. So for the interceptor to actually work, I need to grab I now need to basically do it in a what do you call it, in a JavaScript. So what I'm doing right now is basically, now I'm on submit, I'm triggering this, it prevents the default submission, so the default action. And then what I do here is I post it, so the same thing to the resource, nobody, since we have nobody required, and yeah, I just do that, and that's it. And we need those credentials, so that the credentials, in this case, XSRF token header is actually being sent. Cool, so now we can try. So if we go here now and we press this, everything works as expected. And we can see that in this case, we don't need to send the XSRF token. So, our interceptor doesn't add it to the get method as programmed, but we see that the token is, because it's a safe request, it also doesn't need it on the backend, but the backend gives it a cookie. And you can also see it in a network. You can see that the backend, so this response header, is saying to set this cookie. And then thanks to that, when we send now our post requests, so you see it's a post request, it does get this included in our interceptor, and it is sending it both this and this value. And like I explained before, the backend doesn't save these values itself, it just compares the values. It makes sure that the value that you have here and the value that you have here, so both cookie and the header, have the same value. And if somebody were to try to lure you into some other website and try to make you click something, the cookie will be sent with, but the XSRF token will not be sent with. And the malicious actor has no chance of actually accessing this cookie, because this cookie, as you can see here, is limited to only the domain it was set at, so to our domain, localhost, and it will not be readable on any other website. So yeah, that was it. I hope this was useful, and see you next time.